how many patterns you found, and we'll get a little hands up for describing the pattern. Anyone want to describe the pattern? After?
So basically, the ratio of triangles to squares is 1 to 2.
Right. So we use ratios 1 to 2. Any other pattern you found?
The amount of, so if there's 3 triangles, how much squares?
Doubling, yeah, that's a pattern. Right?
I was going to say an 8-1 triangle and 2 squares, and it's doubling.
Okay, doubling and adding, yeah. Right, yeah.
No matter how many triangles or squares, the total will be multiple of 3. Or will
The total is a multiple of 3. Oh, boom. Didn't even think of that one. Yes, no matter how many there are, the total is a multiple of 3. Even?
I was just thinking, this is just like a doubling with 2 worksheets. The number of squares goes times 2.
Times by 2, yeah. Or doubling, or multiplying by 2. Times is a bit bad. Primary school word. Oh, yeah. Okay, so it multiplies by 1 triangle and 2 squares, going to the next shape. Okay, so there's plenty of patterns we can find. When there's 6 triangles, how many squares would there be? 6 triangles, how many squares? Many? 12. So we came across that in our patterns. It's double, isn't it? 6 triangles, double. Draw that table, so I'll draw what you should have drawn. So we need a table, something like this. I'm going to give them letters. You can, because later on I think we have to use T and S.
Yeah.
So I'm going to say for triangles, squares, T and S, and perhaps you should put in a key when you do that. So when there's 1 triangle, there are 2 squares. When there's 2 triangles, there are 4 squares. I'm just counting here. There's 3 triangles, there's 6 squares, and there's my table. Tables will help you create algebraic formula, algebra formula. And this is our first example. And I'll show you how we create that in a second. When there are 25 triangles, how many squares are there? And how do you know? Be prepared to answer both parts of the question. 25 triangles, how do you know? Algebra. Oh. Giggling. There's 25 triangles each square together. 50, you know, in both times. How do you know? Boom, it's doubling. Yeah, the double amount of squares to triangles. So if there's 25 triangles, Katie said there's 50 squares in each right. How do they know? Because they double based on the pattern. Question 5. If there are 8 triangles, how many shapes? Not how many squares, how many shapes now? Yeah.
24.
How do you know that?
Because you do how many squares are there first, and then you add up the number of triangles. You have 8.
Yeah, so we could create a table for that as well. So let's say triangles and shapes. Well, I've already used S for squares. If I want, I can create a table. If you don't have any of these tables in your book, it might be a good idea to maybe take a note of how to draw a table. So if the triangle is 1, what's the total number of shapes? 1, 2, 3. 3. So there's a different relationship between triangles and shapes. Colin, can you see all the way back there? Yeah, come on. You can? Okay. 2, 6.
You can times the number by 3.
Yeah, I don't need to count, do I? Just times it by 3. So this is a pattern of multiplying by 3, is it? We got some adding 3. Oh. T times 3. Well, maybe we might use that later on, eh? All right, so that is a table to help me answer question 5. When there are 8 triangles, what I've noticed is, well, Priyanka noticed, if we jump to 8, Priyanka's noticed that if you multiply that number by 3, you can get it straight away.
24.
And it's 24, and I think a good few of the groups got that far and sent me that information. So well done. Most people got that. Well done. How do I know? Well, I have created a rule from a table, and I know for sure. Now we must get on to creating some formulas. Frozen here. Let's unfreeze that. The question 7 was our first delve into algebra. Let's move that on the table. It's number. Look at that. Hey, if you have a picture with T triangles, so we're going to use T in my tables here. T triangles, my formula to express the number of squares. Okay. Anyone get a formula? Mathematical formula. This is algebra now. This is complicated, is it? Answer?
So it's basically T times 2, and then that equals S, and then it's plus S equals this.
Okay, so you're saying the number of squares in a formula is now using letters. S is equal to what?
T times 2.
T times 2, like this. S is equal to T times 2. Yeah, I think you're right. So we created our first formula.
Can you write T times 2 equals S? Is that the
No, yeah, you're right. Either way, yeah, T times 2. Now, in algebra, we don't use the multiplication sign. Does anyone know why? That's right. Oh, yeah. Super confusing with X. Watch what X times X times X looks like when I use a multiplication sign. That's what X times X times X looks like if I use a multiplication sign and I don't use an algebraic X. This is what it looks like with an algebraic X. But algebraic X, if you don't know how to draw one of those, draw a C and a backwards C and put them together. Now I don't do that, do I? I don't write X times X times X because that's very confusing. I don't have anything. What do I do?
replace with the dot?
I can use the dot, yeah. So I'll do this in a different color. Even X dot X. Do I put the dot down here or up higher? Yeah, put it up a bit higher because it's not a decimal point. Okay. Still, I'm writing X too many times there. I'm writing it 3 times, multiplying 3 times in a row. Somebody's arm is going to fall off because they know what comes next. Sophia.
X times 3.
X times 3? Brianna disagrees. Yes. X. It's called X cubed. It's X with a small 3 when we do this. This is kind of a side note.
Or 3x, right?
No, not or 3x. Because that'd be 3 times X. 3x is 3 multiplied by X like that. That's 3 times X. So whatever X is multiplied by 3. Notice the difference between those. I hope you're taking some good notes on how to draw a proper X. The difference between 3x and X cubed. I'll put it over here. 3 multiplied by X is 3x. X times itself 3 times is X with a small 3. The number up there is called a power. We're not really going into that too much today. We're just trying to get rid of the multiplication sign from our algebra. Hi, Brian. I'm late. All right. So I know this is not particularly rocket science, T times 2, but it is the start of our algebra adventure. So T times 2, I'm going to rewrite. S is equal to 2 T's. 2T. That's twice T. That's the answer for the number of squares. Squares equals twice T. That's the answer to question 7a. 7b, the total number of shapes. Ashley, you were talking to me about this one. I think the answer to 7b is the total number of shapes.
Is S plus T.
But we can only use, we only know T triangles. So I don't know X triangles or X squares. I just need it with T written.
So it's basically
2T.
yeah, 2 times 2 times 3.
Yeah, I couldn't wait. T times 3, yeah. I saw your work. T times 3, yeah. So I use this additional table. See, I use this table to create T times 3 for the shapes. Is T times 3 this time. It's not, I didn't use S and T, I just used T, because I can get there straight away, which of course is 3T. That's my second formula, 3t. How do I test a formula? How do I test a formula? Nobody knows. Yeah, backward. Yeah, kinda, yeah. Let's ask someone new. Who doesn't want to be asked? Who's going to look away from me when I look at them? Anissa, how do I test the formula? Make sure it works. Panic? Ask the teacher. Is the formula work? Perhaps. Ryan, you know how to test the formula?
So you replace x with a number, and then
X,
you
X
times
here.
the number by the number you times t by, and then
So you're replacing, you're substituting a number in for the letter and see if it works out for something you know. Now I know, because I've drawn it above and it's in the diagram, that I know when I have 3 triangles, I counted the number of shapes as 9. So it's a bit simple here, but I'm going to test 3 times t will always work. So what's t when shapes, triangles are 3? 3 times 3. Is that the same as my diagram? Yes. 3 times 3 is 9. Now it's quite simple here. You know your formula worked because you kind of did it when you were trying to get the formula. But when it becomes more complicated, this thing is called substitution. When you replace a variable. What's that? What's a variable? What's a variable? What's a variable? Theo, what's a variable?
Something that stays the same.
Something stays the same. That's a constant. Mass is a constant. Something that changes, yeah. So what's the only thing that changes in these formulas? What's the only thing, does 2 ever change? Did 2 be anything other than 2 in its life? No, I think 2 is always going to be 2. It wants to be 3, but it's not that good. T changes because you can replace it. It varies. It's a variable. So the letters are called variables because they vary depending on what number you substitute in for them. So when we substitute in for t to test our formula by replacing it with 3, we've substituted in for the variable. So if you don't know what a variable is in algebra, it's the letter. It's a letter that we replace. So maybe take a note of that. We're not entirely sure. Question 9. So remember, the variable is the letter in algebra. Make sure you have that in your notes. And if the number, so if I have, my board's a bit messy now, my apologies for that. Let's get rid of this. Don't want this. If I have a formula, and this I'll use x's. So here's another formula. What are the 2 variables in this formula? What's the 2 variables here? Osborne.
X and Y.
X and Y, they're the 2 letters, they vary. We don't know what they are, and we can plug in values that will work. What's the constant? There's only one constant now here. Which is kind of disagreeing with what I said earlier. Ethan, what's the constant? No, the constant is actually the 1. This is called a constant. The 2 is a constant too, but there's a special name when it's a multiplier. Because that's 2 times x, and it's when it's a constant coefficient, it's a multiplier. Constantly multiplying by something is called a coefficient. Oh, can I spell coefficient? Coefficient. C-E-N. The number in front. Now I see a few people are not writing this down, therefore must know everything. It's always handy because I'll be coming back and I'll be saying something like, oh, what's the variable in that? Can you tell me what the coefficient means? And Oh, if we have our notes taken well, we can just flip back to our notes and we go, hey, I know what variable is, just call and swap these up that one day. Oh, it's December 10th. That's right, it's almost Christmas. As yet. Coefficient, yeah, you can spell it, you can shorten it down to co-e-f-f, as long as you can say it. I-C-E-N-T, did I put an I in C-E-N-T? I think it's just I-C-E-N-T. Oh, it's algebra, coefficient. I think that's actually, I can't remember.
Two questions.
Yes, Ethan.
A coefficient is a constant with a
Constant multiplier, yeah.
and can a variable also be by a symbol?
Yeah. So quite often, on a side note, this doesn't need to go in. Quite often, the variables are not letters. So when we do geometry, you have variables as well. Does anyone know a variable that they've seen in geometry? This might be something you haven't seen. Priyanka. An angle, yeah? So what's the symbol for an angle? Anyone know what the symbol that they use a lot in maths? So it's not that thing. What's an unknown angle? What do they do that? They're measured in degrees, yeah, but not quite what it works out here.
If you don't know how much the angle is,
Yeah, what do you call the angle if you don't know what it is?
I don't know what it's called, but I think I know how to write.
Can you write in your book? Can I see if you're right? Oh, that's one way. Oh, okay. Alpha. Alpha is often used. Beta and omega. They're used.
This is like sorority house.
Yeah. They're very into their geometry, sorority houses. Didn't you know? Okay, that's. Oh, sorry, that's not omega. That's theta. Omega's a different one. Theta, beta, alpha. They're used in geometry. X, Y, usually used in algebra. I is used in something called complex numbers. Symbols, any other symbols used? Not really in maths at your age. Okay, we won't be dealing with these until probably May, maybe April. Okay, but we will be dealing with these all term, next term. Now, this is my side note here. Could I put this in a table with X's and Y's and numbers? Could I convert this? So this is a formula. It's called a formula. You created your formulas with S's and T's in that investigation, didn't you? Yeah, you did. Yeah, you remember it? You remember that? Remember? You don't remember yesterday? No, Tuesday? Do you remember? Yeah. Yeah. So you can use patterns to solve a Rubik's Cube as well, can't you? Yeah, you can. Yeah. Let me do that one after maths lesson. Okay. So I'm going to try and create a table out of this one. X and I need to throw out. Doesn't work. X and Y. All right, X and Y. I'm just going to draw a table. This you definitely should take down because this is interesting stuff. I'm going to draw a table X and Y from the formula. Now I'm just going to put in some random numbers here. 1, 2, 3. When X is 1, when X is 2, when X is 3. Could I find out what Y is? I've put in some numbers here for X. Could I find what Y is? When X is 1, what is Y? Could I solve that? Could I've substituted in? Asher, what's your answer? Okay, when X is 1, so that's going to be 2 times 1 plus 1. What's 2 times 1? 2 plus 1, that's 3. So I can replace when X is 1, Y is 3. Now when X is 2, is Y 3 again? No, it's not. It's a different answer. This formula works in different ways. Often formulas are used to convert stuff. So Celsius to Fahrenheit, if you know Celsius and Fahrenheit, there's a formula to convert Celsius to Fahrenheit. So if there's a different Celsius, there's going to be a different Fahrenheit. If there's a different X, so there's going to be a different Y. Then you'll tell me what it is, Ethan. 5. Anyone get the last one? Pauline? 7. So 3 goes in for X here. 2 times 3 is 6. Plus 1 is 7. You.
If you explain it like that, it's really easy.
Like this is easy? Algebra is easy. You just happen to learn it. And when you, in a few weeks, you're going to say algebra is the easiest subject ever. Randy. Oh, yeah. So I picked 1, 2, 3. Pick another number. Randy, pick any number. 18. So I can put 18 in this table if I wanted as well. Put a little add on. Now, Randy, you're going to tell me what the Y value is when I plug 18 into my formula up here. What does 2x mean? 2 times whatever I've said x is. And I've said x now is 18, so 2 times 18, 36, plus 1, 37. Okay, so I'm just putting values in for my variables, giving them numbers. Adrian. Yeah, you're going to have questions like this for homework, and I see you haven't taken a single word down. It's underneath your bag. Put your bag off your desk, open your book, get a pen, write stuff down. It's all there? All this is there? Not that, no, other stuff. Right around. Yeah, let's write it down. Okay. So this is called a formula. Formula. Awesome. An algebraic formula, if you want to give it its full title, for a relationship between x and y. And here's our relationship in a table. Let's call the table. Now, if I didn't know the formula, but just knew the table, could I find the formula? How? I don't know this, but I know this. I want to find this. Someone tell me how. What's the process, do you think? Rani? Boom! Finding a pattern. That's why we did the patterns investigation. Finding a pattern. What's the pattern? Let's look at the y's pattern. What did the y's jump up by each time? 2. Now there's a bigger jump here. Rani's number was 18. There's a huge jump up here. What's the jump here? 30. What was the jump here though? That jumped 15. Yeah. So 15 times 2, which was our jump when we go up in ones, gives us 30. And that makes sense. Okay. So my jump, let's just leave out the 30 for a second, because I just want to see this consistent jump in the y's. That consistent jump is called a rule. Y increases by 2 each time. That's a rule. Add 2 each time to get the next y. I already know my answer for 4. What would be the 4th term in this sequence? If x is 4, in other words. What's the 4th term? Let's remove Randy's for a second. What's the 4th term in that sequence? I know. 3, 5, 7, 9. So the next term. Okay, so that's plus 2. All right, so our rule is pretty solid here. Looking at the y's. How do I turn a rule into a formula? Where do I see 2 in the formula? Boom, in the coefficient, you have 2 times x. So if I'm adding 2 consistently, what's the answer to the 2 times table? 2, 4, 6, 8. That's a 2 times table. That's multiplying by 2 constantly.
Always adding on.
Boom! We're on a roll here. So I could set up a formula Because I'm adding 2 each time, I must be multiplying by 2 in my formula. So I'm going to start it. Y equals. I'm going to multiply by 2 in my formula, 2x. But 2x doesn't get me to my answer, does it? 2 times x does not get y. Because x is 1. Multiply by 2, well, 1 times 2 is 2. The answer would be 2, 4, 6, 8. Asher just said it. What did you say, Asher?
It's having on one of the.
I just need to add 1 to make this formula work for me. So what did I do? How did I find the formula? Step 1, draw a table. Now in the work you're going to be given a table. So step 1 is done for you. Step 2, what's the rule? Look at the bottom line of the table. What are you consistently adding each time or subtracting each time? It's usually going to be adding. Whatever you're adding needs to be a multiplier in our formula. And then you figure out, do I add something or subtract something that's constantly needed to be added or subtracted? A constant. Okay. It's nice and bright, but I need more of the board. I'm going to ask you now. I'm going to put up 3 tables on the board. And I want you can redraw them in your book if you want, but I want you to create the formula from the tables I'm about to draw. So I'm leaving this up here. I'm just going to use x and y again, but they're going to be different patterns. 3 tables. 1, 2, 3, 4. This is drawn 2. These. 10, 13. That's question number 1. Question number 2. Create another table. Hopefully you can all see this wherever your piece is. If you can't, you can log on to the Meet and you might be able to see it better. Let's go 1, 2, 3 only this time. Let's do 4, 8, 13. So step 1, if you want to redraw the table, redraw the table. Step 2, notice what you're adding each time. What am I adding each time? Step 3, use what I've added to find the formula by multiplying the root. Oh. Two, 5, 7. Yeah, y equals, yeah. Find the formula for y based on the change in x. Or, yeah. Based on the change in y. Let's do this one. 5. 14. Right, if you have any of the answers, any of the formulas, put your hand on, let's check. So any of the 3. If you're not sure what to do, just take down the table for now, and I'll help you with the first one in a minute. You have any of the formulas? That's it. You want the formulas? The rule, yeah. So as you take on the rule, it's plus 3, the first one. That means I need 3 times x in my formula. So start off your formula. Y is equal to 3x, or 3 times x. Well, don't say it out loud. Yes, of course, I'm good. Nice. Yes. Yes. Good. Thank you. So you got the first one. It starts off with y equals. So remember, draw the table. Draw the first table. What are you adding each time? 3, yes. But then, do I need to add or subtract a number to get the formula to work? Yes. So I need to add and subtract. So if you notice, it's adding 3. So you should put the little things I did to show the rule. Do the little lines underneath, plus 3, plus 3, plus 3. So that would be the formula. That would work. Test it. What's 4 plus 3? Not 13. So what I should be seeing on the table, the first table, you've noticed plus 3, plus 3, plus 3. From our example, if we're adding 3 each time, that means 3 times tables every ball. We need a multiplier or coefficient of 3. So 3 times x in our formula. Taking on the table, sir? Have you drawn in little lines with dots around it? So I just do, if you've got the first one ready, all of them? No, keep going. Let's try it on both of them. So y equals 3 times x. Now I need to figure out if I need to add or subtract to get the formula to work. Remember, text. What's 3 times 2? 6. I want 7. What's 3 times 3? 9. I want 10. 3 times 4 is 12. I want 13. So what do I need to add? You figure it out. If you have that answer, do put up your hand and I'll double check. You have the second answer, put up your hand as well. So yeah, what do you? It's not 3xx though, is it? How do I write that? It's not 3xx. Don't write like that anymore. That's hard. You get it using your formula. So 3 times x. So 3 times 1 is equal to 3. So I need to add something to the formula. 3 times 1, yeah, is 3. Plus y is 4. Okay, so that works for the second. 3 times 2 is 6, plus y is 7. 3x plus 1. The test is 9 plus y is 10. Ooh, there. 9. Yes. So y is equal to 3x. 3 times x. So of course, 3 times x. Formula has to work every time. Did anyone crack? You know what? Oh, that would be more. So it's adding 5. You're going to have to multiply by 5. Yes. You have added 5 in the second one, you're going to have that multiplier of 5. This is the first one, the second one, this is the third one. You go help people. Okay, we got 2 minutes left. Yes, nailed it. So, yes, 3 times x, correct. I know, yes, yes, second one? Yes, that's correct. Y equals 5. Well, now I will give you consistent jumps. So 1, 2, 2, 3, yeah. Lisa? Yeah. The last one both are correct. You got it. Okay, so
Did you get 2? Yeah.
3 times x is 9. So 3 times 4 is 12. 13. 13.
What about this?
Is that what here is 9? 3 times 3 is 9. 9 plus 1 is 10. So it must be 3x plus 1. Yes, plus 1. We need to draw that here. Right. Test for 2 and x is 2. If I times 2 is 10. Plus 2 is 12. 2 off. I think it's 2 dollars. I think it's subtract. Okay, the second one? No.
Number 2. Number 2 is the same as number 1. Asher, are you still stuck on number 3?
No, I'm not. It's not 9 times in it. Test your formula. 9 times 5 is going to be 45 is too big. Second one. Okay, so multiply 3x. What is that? 3x plus 1 then? Yeah, so log 3x, 4 times 3 is what? 1 formula. Which is kind of what you're doing. So right now, rising 3x. Okay, I think we're out of time, fortunately. If you need me to check in, just put up your hand or out of time, please. Yes. The third one is a bit tricky, but I think a few people got it. So you guys can mark up now if you're going around this.
So I thought you lost it. I was like,
Oh, that's so easy. Okay. So don't get on mind back for homework. It's going to be formula 3 like this. This you should have got done. No, this won't be for homework, but there's homework on ManageBack that you can do. I think you're all ready for yellow. You don't have to do green, but I think you're all good enough to do yellow. Yes. Monday. We do on Monday. All right.